Hello again, Bio245. This is Vanessa, and I'm here to talk to you about urinary and kidneys. So, I'm going to start off with this super awesome model. This is the best model. You can't see it all. Okay, cool. So, the whole point of our kidney system, what is it? So, basically, it's tightly integrated with controlling the volume of our blood, which is important for obviously controlling blood pressure and stuff, which I'm sure you've learned about in lecture. The other thing it's super important for is balancing pH in the blood, because if you're too acidic or too basic, that can hurt your tissues. It's also really awesome for filtering out extra stuff that we don't need. So for example, too much sodium that you ate in all those french fries and potato chips, it's going to filter that right out for you. Additionally, byproducts of breaking down amino acids like, ammonia and things like that, kidneys will get rid of that for you. So kidneys are your good friend. We should take care of them, and they're super awesome, and I'm excited to talk to you about them today. They are like my second favorite organ following the brain, and you guys all know I'm a neurobiologist, so there you go. So first off, this really awesome model, what is it and what the heck is going on? Well, we've talked about cardiovascular already, so you should notice that this is our inferior vena cava, and here's your descending abdominal aorta. So this stuff should look a little bit familiar. There's your inferior mesenteric laying over like its lazy self. And we can also see our renal veins and arteries going out to our kidneys, right? Renal equals kidney. And you're going to hear renal a lot in the next few minutes, okay? So the whole point of our kidney system is it's going to take this blood supply in, going to filter that blood, maybe remove extra water, get rid of those extra sodium ions and ammonia and all that other kind of nasty stuff that we don't want. And it's going to excrete the stuff we don't want down this tube and return all the blood and stuff that we do want via this vein into the inferior vena cava and back up into the body, into the heart, so it can be cycled back through the lungs and all that kind of fun stuff. Okay? So, first off, here's our kidney. As I've already told you, this tube that's going to carry the stuff that we don't want to be excreted from the body is called the ureter. So not the urethra. Urethra is different. This is the ureter, and its job is just to guide that filtered stuff, in this case urine, once it reaches this point, down into this structure here. This structure here is the bladder. So up at the front here you can see the pubic bones where they're joined. So let's turn this around so you can see a little bit. So there is our bladder. And you can see inside of the, oh, it's been taped shut. You can see inside of the bladder normally. And in this case, you would see it also has rugae, just like the stomach. And also, leading down from the bladder, you can also see the urethra, but unfortunately, this isn't open. So just know that if I had this open, then I would be able to show you guys the urethra, which goes down from the bladder and carries urine out into the world, away from us, right? Usually in a private situation. The bladder is useful because we don't just want the ureters to be hooked up directly to the outside of the world, because then you just have urine dribbling out all the time. So the bladder actually helps to store that stuff. Oh look, it's magically able to open now. There we go. So the bladder is able to store urine for us so we can excrete it at a socially acceptable time, right? So here's the inside of the bladder, and you can also see there's the urethra leaving it, okay? I can also point out the urethra on a reproductive model, but we're going to learn more about reproduction another time, so I think it'll be easier to maybe tell at that time. Okay? Okay, so let's talk more about the kidney, because the kidney is where all that filtering stuff is happening, so we can make urine, so we can excrete it out through the body. So here is our good friend the kidney. So you can see that he looks like a kidney bean, but we're familiar for life. And on the outside of our kidney, we have, oh, it doesn't have it on here, on your list. Here we go. Turn your page over, and on the outside of the kidney, kind of keeping everything bound together, is your fibrous capsule. So you can imagine that we have that dense irregular connective tissue covering our kidney. Okay. Now, at this point, this is a really nice model that I can show you stuff on, so I'll point it out real quick, but then I'm going to turn to these models behind me because they're a little more detailed. Okay. So, moving in from that fibrous capsule, we're going to go to this next layer of the kidney. So this layer here, where it looks pretty homogeneous, see how it's all kind of one solid color? This is called the cortex of the kidney. Okay, the cortex of the kidney. And then if you move deep from the cortex down here where it's a little less uniform, see how we have like these dark colors and there's all this weird stuff going on? This is the medulla of the kidney. So this might sound a little familiar from what we talked about the brain, because we have the cortex of the brain, we have the medulla of the brain, and all that kind of fun stuff. And it's the same kind of ordeal where we have this outer layer that's the cortex, and the deepest part is going to be the medulla. Okay. Now in the medulla, we can see how we have all these tubes and stuff, and we have these dark structures. So for these dark structures here, it's a little bit later on your list, but these dark structures here that are kind of shaped like little fans or triangles, those are going to be your renal pyramids. And it's in the renal pyramids where we have all this filtration stuff happening, and I'll show you guys that in a minute. But that's where you store your nephrons, which we're going to talk about, and they are the filtrating unit of the body. So each of these little pyramids, you can see, is hooked up to a tube. See that tube? There. That tube is referred to as a calyx, and they come in two flavors, minor and major. If it's a minor calyx, it's this tinier tube that's hooked up directly to a renal pyramid. A major calyx, so like, it's hard to point with this tiny model, inverted, there we go. Right there, a major calyx is where we have a couple of other calyx come together. So, for example, we have this renal pyramid and this renal pyramid, and you can imagine that they each have a minor calyx, and they have joined together here, so they are a major calyx there, okay? All of these calyx come together. Oh, here's another really good example. There's a minor calyx, there's a minor calyx. Here it joins together at a major calyx. So all of these calyx come together, right there, into this area right here where I'm poking my finger, this number 4. That is going to be the renal pelvis. So the renal pelvis is like the collecting area for all these calyx. So basically, you have all of these pyramids where the actual filtration is occurring. They're creating urine, so they're filtering the blood and creating urine. Then that urine will dribble down the calyces, so the minors and the majors, and then they're going to fill the pelvis. Ultimately, that urine will then dribble down and out. So let me turn this around so you can kind of see. There you go. So it's going to dribble down and out, so the pelvis is just up in here. Going to dribble down and out the ureter, and then that ureter will go down to the bladder, and then that bladder will excrete urine out through the urethra. Okay? Okay, so that's all I can show you on that model. So let's move on to this model. This is a cool model, okay? I already told you guys I dig the kidney, so I'm going to have a lot of enthusiasm about this. All right. So here's this super cool model. I think you guys will enjoy it. There you go. All right. So same structures, so I'm just going to point out everything basically again. On the outside here, we have the fibrous capsule. We have this more homogeneous layer that is going to be the renal cortex. We have this less homogeneous where we have these dark areas and light areas, and that's going to be the medulla, the renal medulla. We have these dark triangular shapes. Those are going to be your renal pyramids. We have these minor calyx that deposit into a major calyx, and then all these calyx come together to dump out into the renal pelvis, and then it goes out through the ureter. Okay? So let's talk about the slightly finer anatomy of, oh, I missed a term. There's a really weird term that you guys are going to learn in just a second here. You'll notice on your term, just underneath renal pelvis is the hilum or hilum. I always say hilum. But the hilum is just this gap right here. See where this finger is and this finger is? So this gap is the hilum. That's where the ureter exits, the artery comes in, and the vein exits. So that's the hilum. Okay. So let's move on to the finer anatomy. So this is a zoomed in area where we can see the cortex up top and the medulla on the bottom. In particular, we've zoomed in on a renal pyramid. So you can see over here how it's the same color. This is just the same thing but zoomed in. And actually you can see it really great here where we can see all these fine little white tubes right there. So this is the same thing, just zoomed in. So this is a renal pyramid. This is the renal cortex. Here's your fibrous capsule up at the top, right? So this whole thing here where we see this white, long white tube and these loops and twists and turns and these little ball-like structures, all of that together is going to be the nephron. So the nephron is this little ball-like structure right here, this twisty-turny convoluted tubule, this loop, this twisty-turny, and then this tube. All of that together is a nephron. Definitionally, the nephron is going to be the filtration unit of the kidney. That's where the filtration of the blood is occurring, okay? So when we're talking about the nephron, we're starting at this area right here. I know it's a little hard to see there, but they've blown it up over here. Okay, so this little tiny thing where you can see that there's this white circle, white semicircle, and there's red vasculature inside, this is it blown up right here. So this is called the glomerulus. The glomerulus is one of the coolest structures in the body, super interesting. And this is actually one area where we have these arterioles coming in. So we've talked about the cardiovascular, we've talked about arteries, we've talked about veins, and we've talked about capillary beds and all that kind of stuff. So this actually comes in as an arteriole. So arterioles are just small arteries. And it acts more like a capillary bed in here. Once it leaves again, it's still an arteriole, and eventually it'll dump out into a capillary bed. That's an actual capillary bed where we have oxygen exchange occurring. But this is an arteriole and this is an arteriole. So what's the big deal about this glomerulus? What are we talking about here? So this is the place, remember how I said that the kidney's job is it's going to get rid of the excess stuff, so excess fluid, excess salts, waste products that we don't want anymore. That's going to happen here. Well, that's one of the places where it happens. But the blood enters into this guy here. So this round structure is called the Bowman's capsule. The Bowman's capsule. The Bowman's capsule has a slightly negative pressure inside of it, so it's actually going to draw stuff out of this guy here, which is the glomerulus. The glomerulus is actually like the vasculature in here. So it's going to draw stuff out of the glomerulus. So excess water, excess salt, it just leaches right from the glomerulus and fills the Bowman's capsule. Whatever is left exits out of the glomerulus via this arteriole. And I believe you have afferent and yeah, there you go. So the afferent arteriole fills the glomerulus, and then the efferent arteriole here leaves the glomerulus with that filtered blood, okay? So that filtrate leaves the blood, filtered blood exits the glomerulus, and the filtrate fills the Bowman's capsule, and then it enters into this initial tube, okay? So let's go back to over here. So we can see that there's this tiny little ball of vessels, and there's this semicircle that is white. So you can see it dumps out here into this tiny little tube. Hopefully you can see that. So this is called the proximal convoluted tubule. Proximal because it's closest to the glomerulus. So if it's coming right off the glomerulus, it's going to be proximal, okay? Proximal, and then it's convoluted because you can see it's like twisty-turny. Convoluted always just means twisty-turny, turns in and on itself, okay? So like a plot that goes back and forth and all over the place, they call it convoluted. Same idea here. So that's your proximal convoluted tubule. Some people say PCT for short. Then it goes down this loop, okay? See this like long loop that dips down into the medulla, okay? So this dips down in the medulla. Here's one over here that dips even deeper. So that's going to be your nephron loop, or let's see, loop of Henle, okay? So either one of those terms you want to use is fine. Nephron loop, loop of Henle, it's all good. Okay. Then that loop comes back up and drips into this other convoluted tubule. So this convoluted tubule here is called the distal convoluted tubule. And you can see it actually dips back close to the glomerulus, but it's considered to be distal because we follow it like a rope. It's proximal, then we got the loop, and then the loop goes into the distal, okay? The distal then deposits its filtrate into this long tube that will leave the renal pyramid, and that's going to be our collection duct. I believe that's, yes, collecting duct, okay? And I want to tell you just a little bit about what's happening along here, just hopefully that'll help cement some things. So like I said, in the glomerulus, we have filtrate leaving the blood and filling up that Bowman's capsule. That Bowman's capsule drains out into the proximal convoluted tubule. In the proximal convoluted tubule, we have all these capillary beds around it, actually. So you can't see a proximal convoluted tubule here, but imagine that this capillary bed is kind of covering it. So the proximal convoluted tubule interacts with this capillary bed, and they're exchanging stuff back and forth still. So yes, filtrate has gone out into the proximal convoluted tubule from the Bowman's capsule that's come from the blood. But now the body can decide, actually, I wanted some of that water back, or I wanted some of that salt back. I didn't want to put all that stuff out. I want some of it back, and it can absorb it back into the capillary bed here. In the nephron loop, or the loop of Henle, we actually have water regulation occurring more heavily. So and it's at this point where we can decide to conserve water by putting it back out into the body, and we super concentrate our filtrate. So here it's kind of watery filtrate, but past this point, it can be a little more salty, okay, a little bit more concentrated. And the way I think about this is that if you are a critter that lives in the desert, you can have super, super long nephron loops because you're trying to absorb back as much water as possible. You're like, no, I need that water. Like desert rats have super long nephron loops, and by the time they pee, it's like powder because they've reserved so much fluid because of these nephron loops. Then the nephron loop goes here into that distal convoluted tubule, and it's in the distal convoluted tubule where we can regulate salt. So if we want some of that salt back, we can take it back at that point. Or what have you. And then it dumps out here into the collecting duct, and the collecting duct again is another place where we can control water and how much we want to put out or how much we want to keep, okay? Put out in our filtrator, how much we want to keep in the body. Lastly, we have the peritubular capillary bed and the vasa recta on here. Unfortunately, they don't overlap very well in this model, so I'm going to show you a different model. I'm going to safely put this down and not drop it. There we go. This one kind of shows it side by side, so I'll show you this one real quick. This model has all the same stuff: fibrous capsule, cortex, renal pyramids, calyx, pelvis, ureter, all that fun stuff. And we zoom in on the nephrons. It's a slightly different color, but you can see that the structure is the same. Here's our glomerulus, the Bowman's capsule on the outside, proximal convoluted tubule, nephron loops. Distal convoluted tubule is kind of not shown exclusively in this one, but then it dumps out into the collecting duct, and the collecting duct will then exit the renal pyramid, dump out into the calyx all over again, right? So next to this, what you can see are the actual vessels for the glomerulus. So you can see that there's this artery that comes up, or arteriole, and see like this little red ball that represents the vasculature of the glomerulus, okay? So you can actually see, technically, the afferent arteriole, because it's that little arteriole that carries blood into the glomerulus so that it can put filtrate out into the Bowman's capsule. Anyway, you can see that there's this capillary bed going on here, this network, this crisscross hitch hatch of capillaries. So that's going to be your peritubular capillary bed. So peritubular just means around our convoluted tubules, both proximal and distal. You can also see down here that there's this vasculature that would overlap with our loops of Henle. That's going to be where your vasa recta is. So I also have another model that hopefully, here we go, this shows it infinitely better. So you can see here is our Bowman's capsule. So inside of it is going to be the glomerulus and the vessels inside. Here's that proximal convoluted tubule. There's that nephron loop. Hopefully you can see past my hand, nephron loop. Then we have that distal convoluted tubule, and the distal convoluted tubule is super convoluted and eventually dumps out into the collecting duct, which goes down. So surrounding the proximal and distal convoluted tubules is this capillary bed here. That's your peritubular capillary bed. Surrounding your loop of Henle down here, that's going to be the vasa recta. So the vasa recta, again, is going to help reclaim some of that water for us, right? And I have one last model to show you, and then we are done with the kidneys. This one is a weird one and people hate it, but I think it is super awesome, and you'll see why in a second. So again, this is zooming in on our nephron loops and our nephrons in general, okay? So let me kind of break this down for you. Everything's color-coded so you can tell what is where. First off, we have these green ball thingies. That's going to be our Bowman's capsules, which again encapsulate the glomerulus, which is the vascular part, right? Here, coming off this artery, is the afferent arteriole, which will fill the glomerulus with blood, and here's our efferent that leaves, right? So the Bowman's capsule will collect that filtrate. Then it's going to dump out fluid into the proximal convoluted tubule, which is here in beige. So all of this beigey stuff, that's proximal convoluted tubule. The proximal convoluted tubule will then dump out into a nephron loop, which it cuts off on this particular one. So let's go over to this one. Yeah, it's like hidden. So again, here's your Bowman's capsule. Here's your afferent arteriole coming off that big artery, and here's your efferent going into the capillary bed. Here's the beige proximal convoluted tubule, and that convoluted tubule dumps out into the nephron loop, which is right here, and you can see it turns blue after a certain point. And then we have our distal convoluted tubule, which is in this blue kind of color, and then that distal convoluted tubule dumps out into the collecting duct, which goes down all the way and exits out, filling into a calyx. A lot of people get confused because they think that this big yellow guy is going to be a nephron loop. It's not. It leaves, so it's a collecting duct, okay? And here you can see the vasa recta. So the vasa recta, you can actually see loop right alongside all this stuff, right? So vasa recta is going to loop all along these nephron loops. So there you go. There's your vasa recta. And the other thing you can see really well here is your peritubular capillary bed. Okay? So that is the kidney in a nutshell. I've told you a little bit functionally about it, so hopefully that helps you remember what's going on. And I've showed you several different models that I think are super helpful. We can use any of these models on a practical or quiz, so just be aware of them. And I hope you all have a great weekend and a nice week, and we'll see you next time.